Okay, new learning target. It looks like we're going to be looking at trigonometric ratios. Don't know what that has to do with dinosaurs, so let's get these dinosaurs out of here. Goodbye, dinosaurs. Hit the road. Okay, so for what? Oh no, we got more dinosaurs showing up. Hey, there you go, Barney. Yeah, let's move along. Okay, so we're going to be able to use trigonometric ratios. You're like, what on earth does that mean? Well, let's find out what that means. And of course, more vocabulary of right triangles. All right? Of course, we already knew there's right angle. We know that the vertices are labeled with capital letters. C is usually the right angle. Hypotenuse, of course, has to be the longest side across from the right angle. Ooh, identify the angle being studied. It looks like I want to study angle A. Now, look what happens to the legs when I do this. The leg across from the angle is opposite, right? So if I want to study angle A, the opposite leg is now called opposite. And of course, the leg that's adjacent to that angle, well, we call it adjacent, right? Just like our classroom is adjacent to the lunchroom, right? So adjacent just means next to. Now, if I study the other angle, look what happens to the names, right? If I choose angle B, look where opposite ends up. Look where adjacent ends up. All right. So I got to be on my toes. Opposite and adjacent will trade places if I look at the other angle. Some students try to memorize where opposite's always going to be. It doesn't work that way because the triangle can have different orientations, and depending on the angle I want to study, the names opposite and adjacent can end up in different locations. The hypotenuse will always be the longest side. The hypotenuse will also be across from the 90-degree angle. But opposite and adjacent will be placed according to which angle we're going to study. Or we could put a variable in a corner, right? Sometimes a triangle isn't labeled with A, B, and C. And we're like, hey, we'll just figure out the value of that variable, right? So if I got a right triangle, I say, hey, let's put a variable in one corner. Hypotenuse, of course, across from the right angle. Pick one of the acute angles, and we'll stick a variable in there. Oh, what's that you say? Huh. Oh, x. Yeah, you were expecting x for the variable. Yeah, I mean, we use x like all the time in algebra, it seems like, right? But in trigonometry, when we're talking about an angle, we use theta, right? That symbol is called theta. It's a letter in the Greek alphabet. And so if we're looking for a mystery angle, we often use theta instead of x. And so I can then figure out which side is opposite and which side is adjacent because of the placement of theta. And of course, if theta were placed in the other acute angle, opposite and adjacent have to trade places, right? So unlike the Pythagorean theorem where we say, hey, the legs are mix and match, with trigonometry, adjacent and opposite, we've got to make sure we know which one we're looking at. We cannot just have the legs be interchangeable. All right? Hypotenuse is still just going to be the longest side. It's still going to be across from the right angle. But the legs, opposite and adjacent, we have to identify which angle is being studied, which acute angle, right? We don't use the 90-degree angle with the right triangle trig. Yeah, and I just called it trig, right? trigonometry. We often just call it trig. And trigonometry is actually the study of the ratio of two sides of a right triangle. Notice it says two sides, not two legs, right? So two of the three sides. It could be legs, or it could be a leg and a hypotenuse. And ratio, of course, is just a fancy way of saying fraction. So that's all we're ever really looking for. We're just looking for a fraction, right? So if you say, oh no, what on earth is a trigonometric ratio? It's a fraction. The answer is going to be a fraction. Okay, now on the next slide, oh, this is where it's going to get real exciting. It has, oh, no way, even more vocabulary. Man, you thought this was a lot of vocabulary. Here comes a whole nother slide of vocabulary. Okay, so what other words do we have to learn here? Ooh, there are 6 trigonometric functions. But we're going to start with just 3 of them. Usually these 3 functions are introduced and used quite extensively in geometry, but we all know COVID-19 has done some very interesting things, and not every geometry class got through trigonometry. So let's look at the name of the function, how we abbreviate that name, and then the definition. So one of the functions is called sine, right? It's a trig function. We abbreviate it SIN. If you've ever looked at a scientific calculator, you've probably noticed a button that has that on there. Now, when I want to push that button, I still say sine. I don't say sin, right? It's like sine. And for the definition, it is the ratio of the opposite leg to the hypotenuse. The next function is called cosine. It's abbreviated COS. And the definition, the ratio of the adjacent leg to the hypotenuse. And the third function that we're going to work with, tangent, abbreviated TAN. If you can find one of those buttons on a scientific calculator, I bet you can find all 3 of them. They're usually very close to each other. Tangent is defined as the ratio of the opposite leg to the adjacent leg. All right. Now you're thinking, man, this is a lot of vocabulary. How am I going to remember this? Well, a lot of mathematicians, myself included, just think SOHCAHTOA. This is how we remind ourselves. We say SOHCAHTOA. All right. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Right? Sine of theta, opposite over hypotenuse. Cosine theta, adjacent over hypotenuse. Tangent theta, opposite over adjacent. Right? Notice that when I'm actually trying to work with the sine function, I don't just say sine. I need to know what angle I'm looking at, right? So, I'm looking at sine of angle theta, or I'm looking at cosine of angle theta, or I'm looking at tangent of angle theta. Or if the angles are labeled, I could look at like sine of angle A or sine of angle B, right? It doesn't have to be theta. All right, so let's find some trig ratios. Dun, 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 dun. Remember, the answer is just going to be a fraction. All right, so what is the sine of angle A? Okay, now I need opposite over hypotenuse. So what side is opposite A? Well, it looks like 3. Hypotenuse is 5. There's my answer. Cosine of angle A. Well, adjacent to A is 4. The hypotenuse is 5. There's the answer. Tangent of angle A. Opposite over adjacent, 3 over 4. There's the answer. Ooh, sine of angle B. Well, opposite of B is 4. Hypotenuse is still 5. Cosine of angle B. Well, adjacent to B is 3. Hypotenuse is still 5. Tangent of angle B. Well, opposite is 4. Adjacent is 3. You might notice something about the answers for sine and cosine, how they switch when we switch the angle. And also notice what happens to the answer for tangent when we switch angles. And if you're real observant, you might notice something about the answers for sine and cosine. Right? If the hypotenuse is the longest side, in right triangle trigonometry, the values of sine and cosine will also be less than 1. Right? Because opposite over hypotenuse will have to be less than 1 because opposite is smaller than hypotenuse. Adjacent over hypotenuse has to be less than 1 because adjacent will be less than hypotenuse. Okay, let's find some more trig ratios. All right. Sine of theta. Oh, opposite of theta is 8. Hypotenuse is 17. There's the answer. Cosine of angle theta. Well, adjacent is 15. Hypotenuse is 17. Tangent of angle theta. Opposite is 8. Adjacent is 15. There's the answer. Oh no, a leftover dinosaur from that opening slide. Ooh, go away. Oh good, it's being chased away by some cute things. Cool. Okay, so that must mean it is time for our worksheet. So let's get busy and start working.